thermochemical equation, right? So in thermochemical equations, the state of the matter is represented by the symbols like S, N. So as you are going from solid to liquid, this process is endothermic because you are breaking the attractive forces of the solid. And what is the name of this process? Name of the process? It is, I'm not sharing anything. What I'm sharing there? Now, Krista, is it visible now? Okay. Krista, can you see it now? Please confirm, Krista, here. Yes or no? Okay, rejoin the class. Rejoin the class. And rest all can see it? Okay. My request is please join the class at the right time. Again, I'm placing this request that you must join the class at the right time. Okay, so in thermochemical equations, we have to show the state of the matter, solid to liquid. So when some substance is going from solid to liquid, energy is needed, is endothermic. So what is the sign of delta H? The sign of delta H is plus, is endothermic plus sign. Okay, and this is the amount of energy needed to convert 1 mole of solid water, that is ice, into liquid. And the process is called as delta H of vaporization. This is vaporization. So the name of this enthalpy change is delta H vap, which is endo. If I multiply this equation by a coefficient 2, then this delta H is also going to multiply by 2. In that case, it will be 12.02 kilojoules. Now you're not going to say per mole. Oh yeah, Keshav is right. He corrected me. I said vaporization. Keshav is saying no, it's melting. Yeah, for the melting, what is the word, children? So he's right. For the melting, what is the word? Fusion. It's delta H of fusion. Please do the correction. Thank you, Keshav. So solid to liquid is fusion, melting. You can write melting also, but fusion is more popular word. So delta H of fusion for ice, for solid water is 6.01 kilojoules per mole. If I multiply the whole equation by 2, then it becomes this much. But now there is no per mole. So enthalpy is an extensive quantity. Extensive means it depends on quantity. If you change the quantity, the value changes. For 1 mole, for 2 moles, for 3 moles, for 5 moles. So if you multiply your equation by any coefficient, delta H will also get multiplied. If you reverse the equation, let's write down in the reverse manner. H2O liquid to H2O solid. What is this process called as? Liquid to solid, what is it? It is freezing. So you are going to say delta H of freezing. And what's the value of this delta H of freezing? Is it exo endo, children? Liquid to solid, exo endo? It is exo because liquid has high energy. Molecules have high kinetic energy, less intermolecular forces of attraction. Solid molecules are not moving. Intermolecular forces are very strong. So energy is going down, attraction is increasing. Is exothermic. And the answer is, what's the answer? Yes, Krisha, very good. 6.01 kilojoules per mole. Magnitude remains the same because the material is same. There's no change in the chemical formula, chemical composition. So the material is same. So it means its magnitude will also be the same. But here it is needed and here it is released. The process is exothermic. So if you multiply your thermochemical equation by any coefficient, delta H will get multiplied. If you reverse your equation, delta H sign will get reversed. Positive will become negative, negative will become positive. We are clear about it? These are the some application parts of the thermochemical equation. But if I change the state of the matter, like for example, now if I go from H2O liquid to H2O gas, can I call this as delta H vap now? Delta H of vaporization. And what's the value of delta H of vaporization? It's not the same. You cannot take 6.01. It is now different value because the state is different. Delta H of vaporization here is 44 kilojoules per mole. Is endo exo, children? This one? Endo exo? Endo. So it's going to be plus sign. If I write on the reverse process, this is delta H of, yes, delta H of gas to liquid, delta H of condensation, and the value is minus 44 kilojoules per mole, right? Okay, so what is the outcome of this concept? That if you change the state of matter, like liquid to gas, the amount of energies involved are different because attractive forces are of different strength. And then here comes a very popular question that for all substances, this question is very popular. Delta H of vaporization is always higher than delta H of your fusion. Like this one was fusion, right? Delta H of vaporization for all substances. Here also you can see. So what is the reason for that? It's a very popular question. So when you are going from solid to liquid, are you breaking all IMF? Are you breaking all IMF or you are just making them weak so that they are free to move around? What is the change here? We are just weakening them. You're not breaking them altogether. But when you are going from liquid to gas, you remember ideal gases, negligible forces of attraction, negligible IMFs, negligible. You have to overcome all IMFs. Here, IMFs are still there, but slightly weaker than solid. So, solid to liquid, just weakening of IMF. You're just making them slightly weaker. But when you go from liquid to gas, you have to overcome them altogether. You have to break all of them. So in which case more energy is needed? When you are overcoming all IMFs. So that is the reason delta H of vaporization is always higher than delta H of fusion. Is this question answered, children? So please write down this question. This is a question. This can be answered based on the picturization of the IMFs. Solids have very strong. Liquid has strong IMF, but slightly weaker than solids. But these gases, they have negligible IMF. I know it. Theoretical value. Krishna is asking, how did you come to know this? I know it because it's the theoretical value. Okay, Krishna? This I have taken from the table, from the theory given in the books. Okay. This also we have discussed. From here, Krishna. From here. Liquid to gas. Solid to liquid, endo. Liquid to gas, endo. Can you calculate the amount of energy needed to convert 1 mole of solid into? Okay, that question cannot be answered like this because we need to raise the temperature. Okay. I'm giving you one another concept here. I avoided this because if I answer it in that way, my answer would have been wrong. But let's say there is a substance which is going from solid to gas straight away. We call it as sublimation. You know that water cannot undergo sublimation. We know that, right? Like CO2, CO2 solid to CO2 gas is sublimation. Here, the delta H of sublimation, by definition, is delta H of fusion for CO2 plus delta H of vaporization for CO2. Check here, children. Here is the solid. You can see this line, green line, solid. You want to convert this solid into gas. This is gas. We call this as delta H of sublimation. But you know that solid to liquid is delta H of solid to liquid is delta H of fusion. This is liquid here. And liquid to gas is delta H of vaporization. So from this diagram, can I say delta H of sublimation is delta H of fusion and delta H of vaporization? This equation you can use only on the substances which are going to undergo sublimation. Is it okay? Okay, now Kishta was asking something which I missed, I didn't see. She's saying, is these values are given to us? Yes, don't memorize them. We are not going to memorize these values. They will be given to you in the question. Okay, you are not going to memorize anything here. You have to understand how to use it. Okay, in some cases you are calculating it, but with the information given to you, you are calculating it. Do not memorize them. Are we clear with this equation? Okay, can we do this question, children? This one? This is the reaction. This is the delta H of the reaction. Reaction is endo-exo. Is exothermic. They are asking to calculate how much heat is evolved when 266 grams of white phosphorus P4, P4 is white phosphorus, burn in air. We have two types of phosphorus. One is white, other one is red. You know, white phosphorus is very unstable and you have to keep it in kerosene. It reacts with the air. It can undergo combustion very fast to give you P4O10. These are the allotropes of phosphorus. White phosphorus, red phosphorus. Do you know where we are using red phosphorus? The formula is the same. Where are we using it? You have seen these match boxes. Then there is some material here, and then there is a matchstick here. This part and this thing, they are made up of red phosphorus. So it's also combustible, but it's more stable than white. And it's not pure red phosphorus. It's not pure red. It's mixed with some other material to make it harder. Okay, so these are the chemicals. Everything around you, children, are chemicals. Now we have AI, we have internet. AI is so wonderful. So you must check everything that, okay, now this is what material. You just ask from AI. Just take interest in that and you will learn many things. Okay, now let's see this 266 grams of P4. Start with this. You want to calculate delta H? So you convert this grams of P4 to moles of P4 to moles of P4O10 to kilojoules. Can I do so? This is the planning. I'll start with my grams of P4, which is given to me. And I know that for 1 mole of P4, this much amount of energy is released. So I'll plug in this ratio. So let's do it. 266 grams of P4, first ratio. Okay. Yes, please. What ratio I should plug in here? Yes. That's the molar mass of P4, Krisha. Very good. Now, what ratio should I plug in here? Moles of P4 to P4O10. Mole to mole, molar ratio, balanced equation. So 1 mole of P4O10 over 1 mole of P4. What ratio should I plug in here? Now I want to go from moles of, oh, I think I don't require this. I can skip it. I don't require this, children. I can go straight to kilojoules. They're asking how much heat. I calculated the moles of P4 and I can go straight away to kilojoules because I know that 3013 kilojoules of energy is evolved for 1 mole of P4, right? And get the answer. Get the answer, children. Arnav, you have your calculator? Yeah, Arnav, very good. Mm-hmm. What's the answer, children? Yes. Is it 6460? Let me check. I'm getting some other number. 84. Yeah, you're right. And your number should have how many sigfig children? Three. And I think all of you are very, very accurate. 6460. And if you are not placing minus here, then please write down evolved. You have to indicate in your answer that is exo or endo. If you are not placing minus here, then write evolved. If you are placing minus here, that's fine then. There is no need of writing evolved, right? So either you indicate that this is exothermic by a minus sign, or you write heat released or evolved, just to indicate that it is exothermic. Now we started doing the questions, if you remember. This question we did. This also we did in the last class. This also we did in the last class. Can we do this? If you remember in the last class, we were discussing about system and surroundings. System plus surrounding is, system plus surroundings is, universe. Very good, Sarthak. Universe. System for a chemist is the part of the universe under observation. Under observation. Your chemical reaction, whatever you are observing, is the system. Everything around it is the surroundings, everything around it. So here in the A part, the combustion of gasoline in a car engine. You're burning gasoline in car engine. So gasoline is the system. Rest all things around it, the car, whatever is there, is the surroundings. So this process is exo-endo. When you do the combustion of gasoline, are you getting energy or energy is used up? You want to run your car. For running car, energy is, Krishav, I'm talking about gasoline, not about car. Car is the surroundings. Car is the surroundings. Gasoline is the system. So this gasoline on combustion is giving energy so that car can be running, right? You can start the car, you can run the car. Car needs energy to drive, right? Children, are you getting it? Gasoline is the system. When you are burning this gasoline in your car, it's giving you energy and you are using that energy to drive your car. So car is the surroundings taking energy from the system, which is gasoline. So the process is exo. Combustion of gasoline is exo. Okay, answer B part. Water is condensing. So water is going from gas to liquid. So what is water? Water is the system. And what is the surroundings? Pipe is the surroundings. So what is happening? Gas to liquid. What is happening? Exo, yes. So where this heat is going? Who is gaining this heat? Heat is released. Who is gaining this heat? The pipe, right? Energy released, energy absorbed. They should be same in magnitude. Energy can neither be created nor be destroyed. If system is losing, Surrounding is gaining. If surrounding is losing, system is gaining. So this is a cycle of energy in the universe. Okay, C part. CO2 solid to CO2 gas. Solid to gas. This endo heat is needed because you are breaking IMF. F2 gas to 2F gas. F2. F2 is this. This is F2. Lewis dot structure is a molecule to 2F. Endo exo. What are you doing? Bond breaking or bond formation? Is it bond breaking or bond formation? Chiriach. Am I breaking the bond or bond is made? Bond breaking. And bond breaking is breaking of attraction or making of attraction? Yeah, bond means attraction. You're breaking attraction. So it is always going to be endo. So please memorize. You are not going to do error here. And then bond formation is? Bond breaking is endo. Bond formation is? Formation means bond. Bond means attraction. Attractions are formed. More attraction, less energy. So bond formation is exo. Please write it down. We have to keep practicing it. We cannot afford error in this understanding. Okay. So these questions are very simple. They can be multiple choice questions. Now this is the question what we were doing earlier. A thermochemical equation. This is the thermochemical equation. Solid, gas, solid, delta H of the reaction is this. A part. What is given to you? Plug in the ratio. 4 moles of Fe on combustion. It's a combustion reaction. Gives you this much amount of energy. So that's the ratio. So what's the answer, children? The answer is 1652 kilojoules. I didn't place the minus, so I will write kilojoules of energy is, or you put minus. They're asking how much heat is released. So I've written release. This much is released. A part is done. Let's do the B part. So how to start? Start with what is given. 1.00 moles of Fe2O3. Plug in the ratio. Yes, what ratio should I plug in? Go to the balanced equation. What do you want to calculate? Heat. So plug in the ratio of the heat. This ratio. Yes, Krishav, very good. 1652 kilojoules of heat is released when 2 moles of, children, they do it without even writing all these things. You can answer it straight away. Answer is yes, Bhavya. Yeah, 826. Yeah. Kilojoules. If you are writing minus the way Sarthak is writing, you are done. If you are not writing minus, then please in the parentheses write released. C part. Okay, what is given here? All of you, please type here what is given. What is given? 1.00 grams of Fe. Grams of Fe, right? This is given. 3 sig fig. Take care of the sig figs. This answer should be 1650. This is correct. 3 sig fig. Grams of Fe, where should you go? Grams, because I cannot read the equation in grams. Yes, Krisha, very good. Sarthak, very good. Moles of Fe. From moles of Fe, where should I go? What do you want to calculate? Heat. You should go to kilojoules, right? Okay. Shriya, Bhavya, let's do it. Sanvi, 1.00 grams of Fe. Plug in the first ratio, plug in the second ratio, and get the answer. If you're using minus, because it's exothermic, then put minus. If you're not using minus, write released. So give me the answer. Look at the periodic table to convert your Fe to moles. How much you are getting? Waiting for the answer. Answer should come in 3 significant figures because 1.00 gram is 3 sig fig. Arnav, work out the answer. Hmm. Children, pick up your calculator. I have written here. I have done the calculation. I'm speaking also. What you people are doing? Searching the periodic table? Okay, Sarthak is saying minus. Okay. So all of you are getting this? So Arnav, if you are writing 1.85, you write down released next to it. Can you see that I have taken the correct atomic mass? Wow, my answer was not that. Okay. Is the ratio taken by me is correct? So how come I'm getting the answer as 7.39? Shriya, are you getting this? I'm getting this. Why? Why 4? So one student has done error, Sarthak has done error. So all of you are just copying him? You have not done your calculations? Sarthak, if I put this number in the numerator, then this kilojoule will go in the denominator. I'm getting this answer. So those who have answered as 1.85 following this Sarthak, they all are wrong. Shriya, are you getting this answer? Shriya, your answers are not here. Are we getting this now? Check your calculation, children. So what happened? You were not doing any calculations, Bhavya? Oh, Shriya is there with the wrong answer. Shriya H is also there with the wrong answer. Oh, all of you are there. Good. Am I right or you're right? Just check. Can you confirm this answer again? Yeah, good. Okay, I'm right. So it means none of you have done calculation except Sarthak. He answered it, you followed it. So that's not correct. Learning is yours. Sarthak is learning. He's learning from his error. So those who are just copied the answer, maybe I'm wrong, you have not copied, but how come all of you are with the same error? I'm writing on the whiteboard also, but no one is looking at it. So these are very simple questions. Please don't relax. Sit straight, and you should have your calculator, your paper, notebook, everything in front of you. Participate completely in every question and tell yourself that you are going to memorize this unit here in the class only. 4 hours per week is a big amount of time. Use it properly, don't waste it. Memorize here. Now, whatever you are learning, Unit 7, Unit 8, Unit 9, you are going to practice here. You have to do everything here with me. And you will find them very interesting, very simple. Okay, so please, when I say answer, do calculation. Do your own calculations. Okay, now let's see the D part. This is important, very important question. This time, they have given me 10.0 grams of Fe. See, and they have given me 2.00 grams of O2. Check. Both the reactants are given. When both the reactants are given, then it becomes a question of, yes, we discussed this in the unit 4 also. When both the reactants are given, then it's a question of limiting reactant. It's a question of limiting reactant. Means first you have to see which one is the limiting reactant, and then you are going to answer it. Limiting reactant is the one which is finally going to be zero and will stop the reaction. So how to calculate limiting reactant? I have given you 2-3 methods. So I'm going to use here that I'm going to convert my grams of Fe to kilojoules using this ratio, 4 moles to this value using this ratio. I'll get the kilojoules. I'll do the same thing with O2. And then I'll see which one is giving me less amount of energy. Then I'll say, okay, this is my limiting reactant and this is the amount of energy released when these two are heated together with this amount. Right? Okay. So Krisha, ready? 10.0 grams of Fe. Convert this into moles of Fe and then to kilojoules. Krishav, Sarthak, Arnav, you are going to do this part. Girls, you come here. You are going to do this part. Let's see who is going to do faster, the girls or the boys. You're going to take 2.00 grams of O2, 2 moles of O2, and 2 kilojoules. Sathak is already with the answer. Krishav and Arnav, can you confirm? This time, please do your calculations. Last time, both of you didn't do any calculation. You just copied him. He can be wrong. Because you're converting O2 gas to moles of O2 to kilojoules using this molar ratio. 3 and 1 means 1652 kilojoules of energy released for 3 moles of O2. Okay, this time Krishav is getting something else. Arnav, you're doing? What's the answer, Arnav? Sarthak, are you writing every step the way I'm writing? Krista is with the answer, girls. Check her answer. Krista is giving me minus 103.25 K small, J capital. So this time, Sarthak, you are right, and three significant figures, everything is right. So the boys are the winner. Okay, now Krista is giving me this. Shreya, Shreya R, Sanvi, Bhavya, please confirm it. Please confirm this answer. Convert your O2. O2 is not O. Don't take 16 gram as atomic mass. It's 32 grams. It's O2, children. Boys, you start doing this question now. And can you confirm this? Please take O2. Don't take O. Sanvi, if she has given the right answer, 34.4. For which one, Keshav? For O2? No. I'm getting the same answer. Bhavya, you're not answering anything. Check here. I'm giving you the ratio. Oh, I think I didn't plug in the ratio correctly. Okay, okay. I didn't plug in the ratio correctly. Okay, maybe I'm also wrong. Then 1652 kilojoules divided by 3 moles of O2. Can we check now? I think boys are right. It's minus 34.4. So follow the steps. Please don't be in hurry. Follow the step. Do you want to do the same errors in the examination, children? The same error what we are doing here right now. I don't think you can afford these errors in the examination. So why we are in hurry? Let's write down everything nicely, neatly, and try to work out our answer correctly. Accuracy is very important. Okay, Shreya, you are very slow in answering today. Everything is fine. Your health is okay, Shreya. Okay, okay, good. Ready for this question, children? These are, you take it that these type of questions will be there. It's as a multiple choice question or free response. Let's check this. A part. Start with what is given to you. 1.00 moles of H2O. What they want, how much heat is evolved, exothermic. They want kilojoules. What's the answer? It's H2O, children, 2 kilojoules. All of you, please type your answer here in three significant figures. Take the molar ratio. And Sarthak is with the right answer. Bhavya, you have your calculator next to you? Okay, good. Okay, we are doing the B part. A part is done, children. But just check your answers. Yes, Arnav, good. B part. 4.03 grams of H2. This time grams are given and they are asking kilojoules. So what's the plan? You will go from grams of H2 to moles of H2 to kilojoules. So please do the ratio method, get the answer, compare it with others. Don't look at the whiteboard. Just start doing in your notebook. Follow the steps. Do not forget this too. Sarthak is giving us the answer. Keshav, can you check whether he's right or wrong? Krishna, Keshav, Sarthak. All three answers are different. Let's see who is right. I'm also with the answer. I also have an answer. But I'm not telling you right now. Let's see who is going to confirm which one is the correct. Shreya, Shreya, Arnav, Bhavya. Can you confirm which one is right? Two of them are same. Sarthak and Krishna are with the same answer, and I also have the same answer. Yes, good. Okay, now let's do the C part. 186 grams of oxygen. What's the formula of oxygen? That will not be given to you in the examination. In the examination, they will write like oxygen. So what is oxygen? Bhavya, what's the formula of oxygen? So who is going to explain Sarthak that he's wrong? Sarthak is wrong. Sarthak, you have understood? It's a diatomic gas. Yes, very good, Sanvi. We have diatomic gases. No one is going to tell you that these are diatomic. You have to memorize them. There are five of them. Five of them. So they will never write like here they have written hydrogen, but you took H2. Here they have written oxygen, so you're going to take O2, right? So it's 186 grams of O2. Convert that into moles of O2 and then into kilojoules. You're doing it? No, when they say O does not exist, Sarthak, I cannot use O in my calculations because it's not there in the nature. It's a free radical, very reactive. So in none of the question, they will never write oxygen gas. They will write only oxygen. Oxygen means O2, not O. Right, Sarthak? Okay, Sarthak is already with the answer. Kishav, can you check it? Children, do your calculations. I have given you all the planning. I am also with the answer. What about rest of you? Arnav, Keshav, Sanvi, Shriya, Shriyar. Keshav, go for three sick pick and put your answer again. Your answer is right, but sick picks are wrong. Yes. So the answer is 3320 kilojoules. Yes, Arnav. Very good. Bhavya, good. Okay, so we are done with A, B, C. Now, this is something which I have seen in many examination, not exactly same question, but how we can integrate the gas laws with these type of calculations. Read the question. We are doing the D part, children. The total volume of hydrogen gas, H2 gas. So sometimes they write gas, sometimes they don't write gas. Like here, they have not written gas, but this is also H2 because you cannot deal with H. H is very reactive. We don't have H. H2. In Hindenburg, you heard about this Hindenburg from history? It's a very popular, tragic incident, just like Titanic. It's a big aeroplane, luxury aeroplane. For the first time, in the very first flight, it exploded. What are you trying to say, Sanvi? I could not understand the word. Can, can you explain, Sanvi? Hindenburg was an aeroplane, and it was on its very first flight where they were using hydrogen gas as a fuel. You know, we are not using it till now. We are not using this hydrogen gas. Why? Because this hydrogen gas is very, very reactive. It reacts with the oxygen of the air to form water, right? So, this happened here with the Hindenburg. The Hindenburg exploded because they were using hydrogen gas as a fuel. You must check this incident, read about it on the internet. It will make you learn many things. We are not using hydrogen gas till now because hydrogen gas is very explosive, very unstable. It reacts immediately with the oxygen. Okay, now let's start doing this question. So they have given you the volume of hydrogen gas, that is 2.0 times 10 raised to power 8 liter. It's a very big volume, children. The pressure is given, pressure of the hydrogen gas is given 1.0 atm. The temperature at which that aeroplane was kept is also given 25 degrees Celsius. From this information, they want you to calculate kilojoules of energy released when it exploded. Mhm. So, how to do this? What is needed to calculate kilojoules? What is needed? You need the moles of H2. Get the moles of H2 from this. Once you have the moles of H2, you have the balanced equation which can give you kilojoules, right? Yes, Kisha, very good. So, are we ready for this? Somebody was saying use ideal gas law. Sarthak, very good. So, I'm going to use PV equals to nRT. I can rearrange the equation for the number of moles n. So, n equals to PV over RT. I will plug in all these values. Pressure is, these are the moles of hydrogen. Pressure is 1.0 atm and volume is 2.0 10 raised to power 8 liters. I'm checking the units. atm and liters. I'm checking them. Divided by RT. R is, yes, children, 0.0821 liter atm per mole Kelvin. And then it means the temperature has to be converted into Kelvin. So it is 25 plus 273 Kelvin. Temperature in all gas laws have to be converted into Kelvin. Get the answer. The answer is given by Sarthak. Sarthak, can you give me this answer in scientific notation? All of you, please do your calculations because calculation is also something which we have to practice. Remember the numerator numbers, you can take it as such, but when you're starting with the division, denominator, put this thing in parentheses. Sarthak is giving me this answer. Is he right? Let's check that. And he's right. I'm also getting the same answer. What about rest of you, Bhavya, Arnav? You don't have calculator with you? Why you people are not answering the questions at the right time? Krista, please confirm this. Krishav, I think Krishav, you don't have calculator today. Am I right? Krishav, do you have calculator? It's late answer, Bhavya. Very late answer. I could make out the way you are answering. Yeah, yeah, please. Please, children, from today onwards, for every class, calculator is must. Unit 7, so many calculations. Graphing calculator is must. You must have your graphing calculator, Unit 7, Unit 8, Unit 9. You cannot come in the class without calculator. Arnav, you're getting my point? Do you have calculator, Arnav? Okay, good. So these are the moles, but they are not asking the moles of H2. What are they asking? Kilojoules. So you can do this question like this. The energy which they are asking, how much heat is evolved, is 1.0 times 2.0 times 10 raised to power 8 over 0.0821 times 298 moles of H2, which we calculated also. Then you just plug in the ratio from the balanced equation. Minus 572 kilojoules over 2 moles of H2. And you will get your answer. And that's a big, big amount of energy. But how many significant figures should I take, children? How many sig fig? Sig fig I'm going to decide from here. From here. From here. These are the values given to me. So the answer should have 2 sig fig. Again, Sarthak is with the answer. Minus 2.3 times 10 raised to power 9 kilojoules. Is it right, children? Shriya, Shriya H, is the answer right? Hmm. I'm also getting the same. Okay. Okay, Keshav. Now be fast in answering your questions. The answer is right. So this is the application of the thermochemical equations, children. This is how we have to work on thermochemical equations. So we have unlimited number of questions on it. Okay, let's do this one. Let's see how many are there. Okay, this is the last. Hmm. Remember we did one equation that delta E is equal to Q plus W. What is Q here? Heat. W is work. Okay, now they have given me he said that delta H is more positive. You remember that heat, we can convert this into delta H. So in place of Q, I can write delta H. So they are saying delta H is more than delta E. How much more? 2.5 kilojoules more. So the question is, what is this 2.5 kilojoules per mole represents? It is work. See, if this is more, this Q is more, this delta H. I can write the equation like this. Delta E is delta H plus W. Now delta H is more than delta E by 2.5 kilojoules of energy. So what is W, children? W is minus 2.5 kilojoules, isn't it? This W is minus 2.5 kilojoules. Because delta H is more than delta E, so it means work is done by the system. You can see here, it is H2O liquid to H2O gas. What is happening? Expansion. Gas has more volume. Expansion. Expansion means pressure is increasing. This is the piston. So force is applied from inside. Piston is moving up. So who is doing work? H2O gas. The system is doing work. How much work the system is doing? This much. That is the reason delta E is less than delta H. Are we clear about it? Slightly difficult question. Not very popular with AP chemistry. But have you understood this, Arnav? Because I spent plenty of time on this equation. Because you never know when they will turn over into this direction or that direction. They keep changing their style. AP examination people, they keep changing their style. They try to minimize repetition. Okay. Okay, now comes the simplest part of the this particular unit, unit 6, again calculations. Now this time you will be calculating delta H of the reaction. For any reaction like A is reacting with B, giving you C and D. How to calculate delta H naught of the reaction? So there are four methods here. 1, 2, 3. These are theoretical methods. Theoretical. Theoretical means data will be given to you. They will give you information, data, values. You are going to use those values and simple addition, subtraction, and you'll be with the answer. Right? One, two, three. But most difficult is this one. Not difficult means you have to pay attention, you have to practice plenty of questions based on it. This is experimental. You're going to perform an experiment. Like you remember in unit 5, we were doing experiments to calculate the rate law. You were performing 3 experiments, observing the change in the rates of the reaction with the change in concentration, working out order from there. So that all that was experimental. Same here, cup calorimeter, bomb calorimeter will be experimental. You are going to perform experiment. And from the experiment, you will work out the information, the data. You are going to collect your own data and then use equations, calculations to get delta H of the reaction. So first, we'll do these three. They are very simple. The very first is Hess's law. Let's see. Okay, I'm interchanging them. This is 1, this is 2. So first I'm going to use delta H of formation. If you remember from my very first class on thermochemistry, I told you that delta H, delta S, delta G, these are state functions. State functions. Do you remember what are state functions? And do you remember the meaning of this not? Anyone? Not means standard conditions. Standard conditions. Some children, they get confused with standard conditions and STP conditions. These are standard conditions, which is 25 degrees Celsius, 1 atm for 1 mole or 1 molar. Sometimes this is a question, multiple choice question in AP exam. Because many children, they don't know the meaning of this. They don't know the meaning of this. Then we have STP. Do you remember STP, children? This is only for gases. Only for gases. STP. Anyone? 0 degree Celsius, 1 atm, and 1 mole of gas at STP is 22.4 liter. Kavya, Arnav, make a box, write on these things again and again, memorize them. STP, you should know STP because we did plenty of questions on STP. So children, please. They are not given. Yes, Arnav. They will not give you these things. I don't think. Yeah, it's better. Better to memorize them. Okay, now we have, first I'm going to teach you about delta H of formation, the formation enthalpies, the meaning. Very important concept of this unit 6. What's the meaning of delta H? Oh, I was asking one question here. Remember I said state functions. What is the meaning of state functions? State function? Mm-hmm. Sarthak, Krishav, Krista, state functions, Sanvi. State function. They depend only on initial and final state. Remember, I gave you the example of water. I want water at 30 degrees Celsius, drinking water. I told you to bring this water, to raise the temperature of the water from 10 to 30, then you can use any method. You can heat it, you can put it in microwave, you can put it in sun. It doesn't matter which method you are using. It depends only on the final and initial state. Yes. It does not depend on path. Does not depend on path. You can go by any method. Does not depend on path. Sorry, depend on path. If you remember, I told you that W, work, and Q, these are path dependent. You change the path, path dependent. You change the path, the value changes. If you still remember that we were going up on a hill, I said you can go on the hill, just walk like this. You're walking up, or you're moving in a car. You remember this example? Or you're using a chopper and getting dropped over there. So the amount of work done when you are walking up like this, or when you are moving in a car, or when you are just going to drop from the chopper, the amount of work done and the heat involved is different, right? So please do not forget these things. So delta H, delta S, delta G are path dependent. Oh, path dependent or path independent? They are path independent. They do not depend on path. They are state functions. Based on this property, that these are state functions independent of path, we have few equations. One is delta H naught formation of any compound. I'm giving you the compound here, calcium carbonate. This is the compound. I want to calculate is delta H naught formation. So please pay attention to the definition. Delta H naught formation of calcium carbonate by definition is the energy changes when 1 mole of this compound is formed from its elements. So what are the elements? Calcium. What other element is there? Carbon. What other element? No, carbonate is not an element, Krisha. Take elements. Whatever elements are present in it. And what is the other element? Is it O or O2? What should I take? O or O2? You should take in their standard form. So what should I take? O or O2, children? O2. I'm taking the standard form of these elements at 1 atm and 25 degrees Celsius temperature. See delta H naught. Under standard conditions. Under standard condition, whatever form they are existing. This is the equation for the formation of calcium carbonate 1 mole. Balance it. And I'm going to call it as delta H naught formation of CaCO3. And I'm going to use this equation now based on state function. Delta H naught reaction is summation of delta H naught formation of the products. Product is final. Product is final, right? Product. The final state. minus summation of delta H naught formation of the reactant. Now, what is the product here in this equation? What is the product, children? Delta H naught formation of CaCO3. That's the product. See here. Minus summation of delta H naught formation of calcium. The reactants. Delta H naught formation of carbon graphite plus delta H naught formation of O2 3/2. This coefficient will come here, right? But there is an assumption now. Assumption, children. We are going to assume for the pure elements, their delta H naught formation values are assigned as 0 value. 0, 0, 0. So for this reaction which I have written here, delta H naught of reaction is nothing but delta H naught formation of CaCO3. This thing nobody is going to tell you. You have to memorize it. That delta H naught formation value for the pure element is 0. This is also pure element. But how come it is not 0? We are going to take the most stable standard form. Most stable standard form. So which one is more stable, diamond or graphite? Yes, children? Which one is more stable? You know that you are going to learn that all diamonds are very slowly getting converted into graphite. Graphite, very slowly. The rate is not very fast. So if you have diamond, maybe in million years that diamond will be graphite. But graphite to diamond, no. Diamond to graphite, yes. If you remember the structure of diamond, diamond has tetrahedral, you remember? Each carbon, unit 3, each carbon tetrahedrally bonded to 4 more carbon. This is diamond. And graphite, each carbon is bonded to 3 more carbons, and then you have hexagonal layers like this. Then there is one free electron on each carbon. These electrons are delocalized like this. They are delocalized like this. Due to this delocalization of the electrons, the layer structure, graphite is more stable. More stable. You know the reason? I'm going to tell you the reason, and then we are going to discuss it in unit 9. The reason is more entropy. Entropy, S. S is more. High entropy in graphite. Electrons are moving, delocalized. Randomness, more randomness. More freedom to move around. Diamond is packed, tightly packed, compact, very hard. No one can move. Like if I make you sit here in the class for next 3-4 hours and I'll say no one is going to move, you'll become unstable. You'll start complaining. You want to run away. Same here in the nature. In graphite, electrons are moving around, jumping around from one atom to another atom. More freedom there, more randomness, more stable. We are good, children? Are you understanding the word entropy? Big thing in unit 9. Unit 9, children, entropy. Okay. Can you explain O2 is 0, this one is 0, but O3 is this. So which one is more stable, O2 or O3? O2. Are you listening, Arnav? O2 is more stable, children. At 25 degrees Celsius, oxygen is O2 gas. There is no O3 at this temperature, no O3. O3 is at very, very, very low temperature in the topmost part of the atmosphere. There, the temperature is very low, extremely low. You're getting my point? So O3 is not stable at high temperature. Now we are going to practice few equations for the formation. Can you write down the delta H naught formation reaction for liquid water? Yes, please. Write down the formation reaction of liquid water. So what are the elements, Arnav? What are the elements here? Mhm. H2, gas. What else? Is it O or O2? You are going to take O or O2? No, Arnav. O does not exist. Do you have O around you, Arnav? Yeah, so yes, O2. There is no O in the atmosphere. There is no O in the lab. There is no O around us. We have O2. This is for 1 mole. Write down their conditions. Gas, gas, liquid. Check the value here. H2O liquid. Delta H naught formation for water liquid is minus 285.8 kilojoules. These values will be given to you. Check the value of hydrogen gas. We are checking for hydrogen gas, children. Here, hydrogen. 0. We are checking for oxygen gas. 0. So these are 0, 0. So whatever amount of energy change taking place over here is assigned as delta H naught formation for liquid water. Can we write down the formation of ammonia? Ammonia gas. Can we write down this? Mhm. For 1 mole Sarthak, N2 gas 3/2 H2 gas is giving you 1 mole of ammonia for 1 mole, right? By definition for 1 mole. And look at the value of ammonia is given here. Okay, so that's the meaning of the formation and how to write on the reaction that we should keep practicing. Now I am going to use this information of delta H naught formation to calculate the delta H naught reaction. This equation is valid in delta S naught reaction also. Same equation. Delta G naught reaction in unit 9. Same equation I will be using there. So it is the sum. See the sum of the formation enthalpies of the product, final state, minus the formation enthalpy of the reactant. You have to take care of the coefficients. Like this is the coefficient of the balanced equation. You multiply your delta H naught formation by this C. So ready to do some questions based on it? So I'm going to give you one equation. And you are going to calculate delta H naught reaction, all of you. Ammonia is reacting with carbon dioxide. This is a gas. This is a gas and is giving us, one second, I have to check this information. No such information. So I'm giving you another question. Depends on what information is given to you. Me, accordingly, I can make a question here. MgO is reacting with CO2, giving you MgCO3. This is solid, this is gas, this is solid. Calculate delta H naught reaction value by using formation enthalpies. Formation enthalpies will be given to you in the examination. This is for MgO, this is for MgCO3, this is for CO2. We are doing it. So I'm writing the equation to make it very clear that I'm going to sum up summation of delta H naught formation of the product. I have only one product, so MgCO3 minus summation of the delta H naught formation of the reactant. I have two reactants, MgO plus of CO2. Just plug in the values. Values will be given to you. Just plug in the values. So MgCO3 is minus these two. MgO is minus 601. Take care of the sign of these delta H. CO2 is minus 393.5. Work out the answer, children. Here no coefficient is there, so all of them are 1, 1, 1. What's the answer? Sarthak is giving me 117.6 units, Sarthak. And he is representing answer in the correct significant figures because here these are simply addition subtraction. You're not multiplying. For addition subtraction, you are going to go for minimum decimal places. Yeah, you can write per mole because this is one mole. Is this right, children? Anyone doing it? I think it's wrong. Is it right? Can you check, children? Oh no, it can be right. Okay, I have checked the answer. Anyone else doing it? Krishav, you are checking? Bhavya, Arnav, are you checking answer given by Sarthak? Yeah, it is correct. Sig figs are correct. I have to express my answer up to one decimal place because all the numbers which I have taken, they are up to one decimal place, minimum decimal places. Ready for another question? H2O2. This time I want answer from all of you, please. You have to practice this equation. Giving you H2O plus O2 Balance the equation. Calculate delta H naught reaction from the formation enthalpies here. Formation enthalpies will be given to us. And they will not give you formation enthalpy of the O2 gas. O2 gas will not be given to us. So ready? Don't wait for Sarthak to give us the answer. I'm doing it on the whiteboard. If you are unable to do it, unable to understand, just follow me. I will not be speaking anything. So do your calculations nicely. Is this the final answer, Sarthak? You did one big error. One is H2O2, Sarthak. These are the products, summation of products, and this is the reactant. I'm using this equation, children. Plug in the values. Water liquid. O2. Who is going to tell me about O2? O2 is delta H naught formation value of O2. Pure element. Yes, Keshav, very good. 0. Minus 2 times H2O2. Solve it and check what Sarthak is telling us. Is it right or wrong? And decide whether the reaction is endothermic or exothermic from the sign of delta H. This is minus, children. What's the sign of delta H here? Negative or positive? I feel that it should be negative. Bhavya, Arnav, is the answer negative? Sanvi, Krista, is the answer negative or positive? Yeah, so it is exothermic, endothermic. It's exothermic. Please inform your parents that I want to speak to your parents next week so they can join me before the class. I'll send an email also. Okay. So we can discuss. Let me see what parents want from me. And let's see how can we, like, you people are not doing quizzes, not doing tests. So now this is very high time that we start doing things in a systematic manner. Yeah, tests are also there. Chapter test, I show you then, Arnav. And then after this finishing of the syllabus, after that, I'm going to enroll you in review classes. You people have already paid for it. So in the review classes, you will get real AP question papers, all past question papers, their questions, and full test from every unit. So there are plenty and plenty of questions. Big question bank is there, but you have to use it, right? Only answering here in the class is not sufficient. Start doing the quizzes, children. I'm going to clear it. So we have understood the meaning of the formation enthalpy. Now the next important thing is Hess's law. Hess's law is really very easy, fun, very fun. Okay, you will enjoy it. But you have to listen to me carefully, follow me, and practice the questions. What is Hess's law? You remember I said that enthalpy is a state function? It doesn't matter how you get there. It doesn't matter what is the path of the reaction. It doesn't matter. I can carry out a reaction in multiple steps, and then I can work out the delta H naught of the reaction. So Hess's law, I'm going to show you the meaning of Hess's law with some example here. Let's say A is reacting with B in a single step, giving you C and D, that's the product, and delta H of the reaction can be calculated. But other students said, no, I want to convert A and B first into E and F, then into C and D. So the reaction is done by a different path. First, A and B are converted into E and F, and let's say this is delta H1. Then E and F are converted into C and D. You know, remember the elementary steps from the kinetics? These are intermediates, right? E and F, when you add them, what's the final equation? Final equation is A plus B giving you C and D. This is the mechanism. The reaction is taking place in multiple steps. This is delta H2 naught, right? So when I add these two reactions, this is delta H naught 1, this is delta H naught 2. When I'm going to add, I'm going to get this final desired equation, this equation. And the delta H of this reaction delta H of this reaction is nothing but delta H naught 1 plus delta H naught 2. That's the delta H of the reaction. Is it okay? This is Hess's law. Whether I carried out the reaction in single step, or I carried out the reaction in two steps, or I carried out the reaction in more than two steps. Like I can do it like this. A plus B is converted to not D, let's say G. Then G is converted into Q, and then Q is converted into C and D. So this is delta H3, delta H4, delta H5. So whether you carried out your reaction by this step, this one, or you carried out by this step, or you carried out by this step, multiple paths, but delta H naught of the reaction will always remain constant, and it is equal to delta H naught 1 plus delta H naught 2. If I'm going by this method, which is also equal to delta H naught 3 plus delta H naught 4 plus delta H naught 5, this method. So it doesn't matter. It doesn't matter which path we are following because delta H is state function. It does not depend on path. You can follow any path. The delta H of the reaction will remain same, will be constant. So let's do this question based on Hess's law. Calculate the standard enthalpy of formation of CS2. That's the desired equation. So can I write down the equation? The equation which I want. Formation of CS2. Liquid. Formation. Delta H naught formation. So what are the elements here? What are the reactants? You know how to write on the formation reactions now? Yes, very good. Carbon, which is solid. In fact, graphite and sulfur, which is rhombic. So don't worry, you simply write sulfur solid. Balance the equation too. Now you're going to use these three equations. These three. You can multiply them with any coefficient. You can reverse them. You can flip the equation. You can multiply it depending upon what do you want. What is your desired equation? Just focus on your desired equation. I'm doing this question, so you are going to listen this very nicely because the next question you people are going to do. I will be looking at my desired equation. I want carbon solid. So I will see that which equation is giving me carbon solid. This one, this one. And I want carbon solid on the reactant side. So I'm going to take this equation as such. Carbon solid plus O2 gas giving you CO2 gas. So delta H naught 1 I have taken as such. This equation I have taken as such without any changes. Now I will check 2 sulfur. 2 sulfur I'm going to get from this equation. This one. But this equation is for 1 sulfur. I need 2 sulfur. So I'll multiply the whole equation by 2. So I will get 2 sulfur plus 2O2 gas. Sulfur is solid, giving you 2SO2 gas. And delta H2 is multiplied by 2. Because I multiplied the whole equation by 2, so this is multiplied. Then I have to see my CS2 liquid. Which equation is giving me CS2 liquid? This one. Shall I take it as such? Or should I flip it? Because I want CS2 liquid on the product side. And here it is in the reactant side, you can see. So what should I do, Arnav? To get it on the right side, I'm going to, yes, Arnav. Keshav, Sarthak, we should flip the equation. Very good, Arnav. Excellent. So flip the equation. CO2 gas. When I flip the equation, what happens to delta H value? Delta H value will become negative to positive, positive to negative. Sign will get flipped. Means I'm going to write minus delta H naught 3. If it is negative, it will become positive. If it is positive, it will become negative. Now add these reactions. Add. Add them. Okay, I'm adding, children. After adding, I should get my desired equation. Desired, the one I want. I should get that. If I'm not getting that, I have done some error. Okay, let's see what all is cancelling out. 3 oxygen cancelled. CO2 cancelled. 2 SO2 cancelled. What is left? I'm left with my desired equation. All rest are cancelled. And what's the delta H of the reaction? This reaction is the sum of all these. I added them, so they will get added. Delta H naught 1 plus delta H naught 2 minus delta H naught 3. And the answer is, you were correct earlier, Sarthak. If you see, you are doing addition subtraction. You have to express your answer only up to 1 decimal place. Addition subtraction? Oh, no decimal place, in fact. There is no decimal place here. Yes. See, Sarthak is listening very carefully. So, children, when you are answering here, when I'm discussing, you are giving me simple answers. It gives me confidence that you are listening. Otherwise, I feel that, oh my God, maybe they are sleeping on the other end. Bhavya, you're there? Are you getting this answer? 86 kilojoules. Good. Okay, perfect. So, ready for a question, children? Okay, I'm going to show you one question. This one. So, this is your desired equation. All of you, please now answer here because you have to learn it by doing. If you don't do it with me, you won't be able to learn it. Delta H1, delta H2, delta H3. Equation 1, equation 2, equation 3. This is my desired equation. Desired. Okay, I want CLF. And do not worry about anything else. Just focus on CLF. Which equation is giving me CLF? And how should I take it? Sarthak is saying equation 1. But how many CLF you want, Sarthak? 1 or 2? Only 1. So what should you do with equation 1? Are you going to take it as such, or are you going to flip it, or are you going to divide by 2? Yes, yes, very good. So take equation 1 as such, but divide by 2. Because I want only 1 CLF. So I'm selecting the equations, and what I want accordingly, I'm doing the changes. So what will happen to my delta H1? Yes, what will happen? I divided the whole equation by 2. So this will also get divided by 2. Yeah, we can leave it here, Sarthak. Now I'm going to focus on F2. Just focus on F2. Do not worry about anything else. Which equation is giving you F2? How should I take this equation 3? Only Krishav, Sarthak are answering. How should I take equation 3? as such or divide by 2? You take it as such, but divided by, as such means don't flip it. So I'm going to divide it by 2 because I need 1 mole and here we have 2. See? So divide by 2. And F2O. So delta H3 divided by 2. Now I want ClF3. Now girls, please answer. ClF3. Which equation is giving me ClF3 and what should I do the equation so that I can get ClF3 on the product side and only 1 more? Yes, please. Bhavya, Krishna, Sanvi, Shreya R. Shreya H has some internet problem. Mhm. Equation 2. Perfect. That's the answer, Krishna. Perfect answer. So take equation 2, flip it and divide by 2. So it will become half Cl2O plus 3 over 2 F2O, giving you ClF3 plus O2. So what happens to delta H2? Minus delta H2 divided by 3. I told you not to worry anything. Not to worry about F2O, not to worry about O2. Check, not to worry about Cl2O. They are intermediates. Now you add all these 3 equations. When you are going to add these 3 equations, they should cancel out. Check, are they canceling out? What all canceling out, children? Oh, 2. Thank you, Krisha. Divided by 2. Because I divided the whole equation by 2. Yes, you're right, Krisha. Now, can you tell me what all cancelled out? Is this cancelled out? One on the reactant side, other on the product side, cancelled. Half O2 plus half O2 is 1 O2, right? And 1 O2 here, cancelled. Half F2O plus F2O is 3 by 2 F2O, isn't it? What is left? ClF plus F2 giving you ClF3. My desired equation is here. What's the delta H of the reaction? The sum of all these with the changes. Delta H1 over 2 plus delta H3 over 2 minus delta H2 over 2. Plug in the values with their sign and you will get the answer. So this is Hess's law, children. So in this presentation, I have added nearly 5 or 6 Hess's laws question. Tomorrow when I start the class, I will start from Hess's law. So please check on the website. The PDF is already uploaded. Hess's law is a separate topic. And you can check that you can read it, you can understand it. Book is also uploaded. In the book, the question PDF of the book, there is a separate section of the Hess's law. I've taken all these questions from there, from the book only. You can see more questions. This is also based on Hess's law. I'll add a few more questions from the book. So come prepared. So I think today I can end the class now. In case you have any questions, you can stay back. See you tomorrow then. See you. Bye.